Lecture 27, review covariant derivative using the key point. Key point is the property of the covariant derivative of v respect to x. X is not necessarily a tangent vector. Now, again, key point, okay, this is a property of the covariant derivative which we showed, okay, previously in the video. So x is xj, you see, partial xj here, capital X. This is this I developed this here. There's a property. This xj, you see, covariant derivative of this basis vector vk. Now, partial respect to xk. Okay, there's a basis vector. Okay, this is a property of the covariant derivative. Now, let's apply Leibniz rule for the derivative of the products. Product of what? Of function and basis vectors. Now, let's apply, okay? This is a Leibniz rule, okay? So this xj partial xk, okay? Plus xj vk. This is covariant derivative of xj xk. Now, recall that, by definition, this is Christoffel symbol of second kind. You see? That's we define the Christoffel symbol like that. Hence, now, I just substitute. Now, covariant derivative of v respect to x, the covariant derivative is xj. Now, I just repeat over there and substitute this term over here using the Christoffel symbols. Since k and m are dummy indices, I can swap k by I, m by k, m by k. You see? And this here, I repeat, because this I have a partial derivative of xk, and this is partial derivative of xk. You see? So this, I just substitute and write this expression over there. So in terms of components, okay? Now, covariant derivative of x of vk, just components, okay? And then I omit this partial respect to xk, this formula. Again, observe that x is not necessarily a tangent vector to the curve gamma of lambda. You see this figure here? Lambda is a real number, okay? This point here is a fantasy, okay? I call this point here xi of lambda, okay? This xi belongs to the manifold. It's just a label, okay? Because all the calculation we do using the real lambda over here. You see, that's important. The covariant derivative using the key point. What is the key point? Is the property of the covariant derivative, you see, of v respect to x.